So here we are going to start the next exercise 7.2, and from that exercise if we consider the first example is like this: find the cube root of each of the following numbers by prime factorization method. That means again we are going to use the prime factorization method which we are using in the previous lectures, so that only we are going to use same method. And but here the different question is there. In the earlier stage we had considered that find the smallest number by which we are going to multiply, or find the smallest number by which we are going to divide so as to obtain perfect cube number. But here already the perfect cube number is there, and we have to find out cube root, that means of which number that cube is, that we are going to find out here in this question number 1 from the exercise 7.2. Now first and second example are little bit easy, that means they are very easy. So I know that you are going to solve it anyway, so that's why we are here considering the third and fourth example, which is little bit higher order examples. So that's why I'm going to take the third and fourth example. So first and second example you can easily solve according to this third and fourth example. Now the third example is like this: 10,648, and we are going to find out the cube root of this number 10,648, and for that purpose we are going to use the prime factorization method. That means we are going to use the prime factors like 2, 3, 5, 7, 11, like this. So here while considering the prime factorization of this number 10,648, so for that purpose we are going to consider first prime factor as a 2, because it is an even number. So if we consider the number 10,648, then it is an even number. So therefore first prime factor we are going to take as 2. That means we are going to divide it by 2, and after dividing this 10,648, we are going to get the answer 5,324, which is again a even number. So that means again we are going to divide it by 2. Again we are going to divide it by 2. Again, by dividing this number 5,324 by 2, then we are going to get the answer 2662, which is the question for after dividing this 5,324 by 2, we are getting the answer 2662, which is again going to be even number. So that's why again we are going to take 2 as a prime factor. That means again we are going to divide it by 2, and then we are getting like this. After dividing it by 2, we are getting 1331. 1331, we are getting this number. Now actually this 1331 is a odd number, is a odd number. And if we are going to divide it by the next prime factor, which is 3, then it is found that this 1331 is not divisible by 3. So we can see that division now here. 1331 divided by 3. So if we divide it like this, 3 4s are 12, 3 4s are 12. So 13 minus 12, 1 is remainder. Then again 3 is carried down side as it is. So again 13 number is obtained. So again 3 4s are 12. Again 13 minus 12 is 1. And if we brought that 1 to the downside, then we are getting the 11 as a remainder. And we know that 11 is not present in 3's table. So that's why this number 1331 is not divisible by 3. So we are going to move to the next prime factor, which is 5. And we know that the given number is divisible by 5 only if its end point or end digit is 5 or 0. Then only we can divide it by 5. So here 1 is there, so it is not divisible by 5 also. So after 3 and 5, now we are moving to the next prime factor, which is 7. After 3 and 5, now the next prime factor is going to be 7. So again we are going to divide it by 7. So again 1331 divided by 7. So next prime factor we are going to take 7. So we cannot divide by using 5. So that's why we are taking 7, next prime factor. So here 7 ones are 7. So just perform the multiplication. 7 ones are 7. Then perform the subtraction. 13 minus 7 is going to be 6. 13 minus 7 is going to be 6. Then we have to brought that 3 as it is. Next digit is brought down as it is. So we get the number 63. And we know that 7 nines are 63. 7 nines are 63. So again 63 minus 63, 0. And this 1 is remained. So we have to bring that 1 to the downside. And we know that here we cannot divide this 1 with the help of 7. So therefore again dead end is here for 7. So that means we are not able to divide it by 7 also. That means we have to skip these first 3 prime factors. It is not divisible by 3. It is not divisible by 5. It is not divisible by 7 also. So we are going to move to the next prime factor, which is 11. And now this number is divisible by 11. Now this number is divisible by 11. So after dividing this number by 11, we are getting 121. 121. Then we know that 121 is the square of 11. So that means obviously it is going to be divisible by 11. As it is a square of 11, then obviously it is divisible by 11. And after dividing it, we are getting 11. Again, this 11 is divisible by 11. And finally, we are getting the quotient as 1. And when we are getting the quotient as 1, then our prime factorization is completed. So therefore here prime factorization of 10,648 is also completed. And if we indicate that number in the form of prime factors, then we are going to write down it like this: 2 into 2 into 2, then 11 into 11 into 11. So here both the prime factors are in triplets. So if you observe it carefully, both the prime factors are in the form of triplets. So obviously this number is going to be perfect cube number. And in order to find out the cube root, we are going to take each prime factor from each triplet. So from the first triplet, one prime factor we had taken, which is 2. And from the second triplet, we had taken 11. And if we take the product of these two numbers, 11 into 2, then we are getting 11 2s are 22, which is the cube root of 10,648. So now the next example, which is fourth sub question from the question number 1. The number is 27,000. The number is 27,000. Okay. Now, if we consider again this number, which is very higher, that number is again very higher as compared to 10,648. It is now much higher. That means near about 17,000 higher. Now, still we have to find out the cube root of this very higher number also. And for that purpose, again, we are going to use the prime factorization of 27,000. Now, same methods again we are going to follow while considering the factorization of 27,000. Again, we are going to consider whether that number is odd or even. And if we consider that number, clearly it is an even number because lastly 0 is there. So if generally 0 is present at last, then that number is actually even number. And we had also seen that property of cube. Cube numbers having 3 zeros in it. How many zeros are there? 3 zeros are there. So here also 3 zeros are there. So that means it has cube root. So it is a perfect cube number. So here now, first of all, I'm going to divide this 27,000 with the help of 2. So we have to make half of the 27,000, which is 13,500. 13,500. Again, this 13,500 is considered to be even number because it is a even number. So again, we are going to divide it by 2. After dividing it by 2, we are getting the number 6,750. 6,750, which is again even number. So again, we have to divide it by 2. Again, we are going to divide it by 2 because it is an even number. After dividing it, now we are getting 3,375. And as we know that the number having 5 at last, that means it is ending with 5, then definitely it is going to be odd number. And if it is ending with 5, then it is divisible by 5. If it is ending with 5, then it is divisible by 5. But first of all, we have to check the probability of 3 also. We have to check the probability of 3 also. That means whether it is divisible by 3 or not. So 3,375 divided by 3. So here 3 ones are 3. So 3 minus 3 0. Again, we have to bring next 3 to the downside. Again 3 ones are 3. Again, remainder is 0. We have to bring next 7 as it is. Then 3 twos are 7. Remainder is 1. After subtracting that, 3 twos are 6. Remainder is 1. And again, we have to bring that 5 to the downside. So we are getting the number 15. And we know that 3 fives are 15. So that means this number is divisible by 3. So that means there is no need to move to the next number, which is 5. So therefore, we are dividing it by 3 and we are getting the answer 1,125. Again, we have to check the probability for 3 for next number 1,125, which is again divisible by 3. We are getting the answer 375. And again, this 375 is divisible by 3. So therefore, we are getting the answer 125. But here, 125 is not divisible by 3. So therefore, we have to move to the next prime factor, which is 5. And I told you that how to identify that given number is divisible by 5. That number should be ending with 5 or 0. Then only it is divisible by 5. So here this number is ending with 5. 125 is ending with 5. So therefore it is divisible by 5. So we have to divide it. We know that 25 fives are 125. So if we see the 25 table, then in 25 table we can count like this: 25 fives are 125. So therefore next number is 25. Again 25 is divisible by 5. 25 divided by 5 is going to be 5, and this last 5 is again divisible by 5, and we are getting the quotient as 1. 5 ones are 5. So therefore quotient is 1. So our prime factors are ended. That means we cannot go further. Now here, if we observe, 3 prime factors are repeated. First one is 2, second one is 3, and third one is 5. And if we see the proper arrangement of those prime factors, then 2 is repeated 3 times. 2 is repeated 3 times. That means first triplet is formed. Then again 3 is repeated 3 times. So second triplet is formed. And third triplet is of 5 because third prime factor is 5. So all the prime factors are in a triplet. So therefore it is clear that we can calculate the cube root of 27,000. And for that purpose, we are going to take each prime factor from each triplet. So from first triplet, we had taken 2. From second triplet, we had taken 3. And from third triplet, we had taken 5, and now just perform the multiplication of these 3 prime factors. 2 into 3 into 5. So 2 3s are 6 and 6 5s are 30. So therefore we can say that 27,000 is a cube of 30, or cube root of 27,000 is 30. So in this way we can use the prime factorization method, and by using that prime factorization method we can solve the, or we can obtain the cube root of given equation.